So this is my machine I made. It was designed to create pressure from biological sources, like say yeast and sugar. A giant vat of yeast and sugar would go to making a bunch of pressure for this machine to operate. Its eventual goal would be to generate electricity, but I need a better transmission. This is only one step up. I need like 30, but it works anyhow. Here's how it operates. Here's my pump. Right now I'm using it instead of yeast and sugar or whatever it is I wanted to use to create pressure. Right now this is just what I'm using to test my machine here. And what it does is it generates air that goes through this line and eventually into this valve. This valve right now is open, so the air will continue through this tube down to that bucket down there. That's the master cylinder. Right now it's got water in it, maybe about this much water. And what I'm doing is I'm pumping air into the top and pushing that water level down. Well, where's the water going? It's going into this green bucket. It ends up going through this hose here. So the water presses down, sends the water through this hose, and it fills this green bucket. Once that green bucket fills, it begins to lift this black bucket, which is set inside of it in a way that they won't be stuck together for fucking forever. In here, there's just a bunch of bricks. Mostly air, but bricks. It weighs a lot, but it wants to float when there's water in the green bucket, which right now I'm forcing there to be. This bucket, which weighs a lot and floats, is connected to this chain. It goes to this counterweight eventually. This is just a bearing and a sprocket, that's what it's called, to a bicycle. And what ends up happening is when that bucket goes up, this counterweight, which is like a steel pipe filled with bricks, goes down. And this counterweight assumes the position of power for the whole machine. It's what's making this go. Whenever I put air in, I make it go down, and I make this turn. Although it's all so very slow, I need to speed up my transmission. It's so slow that you can't see anything happening. But there is something happening. That bucket is being lifted, the counterweight is going down until it eventually hits this lever. And what that lever does is, say right now, this valve is open. This is the air intake valve. Right now, it can intake air, and if the pump were disconnected, it would leak air out because this valve is open. When this counterweight goes down from the machine's process, it will press this lever. There's some adjustments to be made, so right now I have to do it manually, but eventually it will press this lever down, and what happens is it exhausts its air. This air intake will be completely shut off, so now I can disconnect the pump and it'll still exhaust over there and not back through the air intake. This other valve over here, this one, which is now opened, it can do its primary function by letting air out of the master cylinder. So what happens is this valve opens and it lets air out through this hose and into the bottom one. The bottom one I just have in this Gatorade bottle. All it does is show me whether or not there's air coming out of it, which there is, because it's making bubbles. This can be used as a turbo to generate extra air pressure for the machine when I figure that out one day. But yeah, that's pretty much it. What happens now is that this bucket's letting its air out, and now this bucket is draining because of gravity back into this one, at least half of its water, which is more than enough for that black bucket to go back down. It's just pushing the water back where it was. And what ends up happening is this counterweight goes up instead of down like it was earlier. And eventually it will trigger this lever to go back up, and the exhaust will shut off, and I can begin building air pressure again, even though my pump's disconnected. But yeah, that's how it works.